This is lesson 6.6. In this video, we're going to work on solving problems using quadratic models, so real-world problems. So our learning goals are for you to be able to solve problems modeled by quadratic relations using a variety of techniques that we learned throughout the past few chapters, so factoring, quadratic formula, completing the square, so on and so forth. So these are a few general tips when you're solving problems, how to increase your likelihood of being successful in doing so. You want to make sure you write down all the important information from the problem. Sometimes it's given to you in these paragraphs or long sentences. You want to make sure you can decipher what's important from it. It's important to be able to sketch the scenario and label your sketch with as much information as possible just to make it more visual and easier to understand. And then you want to think about what the problem is asking. So if the problem is asking you for a maximum or a minimum, do you want to find the zeros or the vertex? What are you doing there? So if you know what the problem is asking, then you can make a plan in terms of what you're looking for. If you're given a vertex, think about maybe using the vertex form, maybe using completing the square. If you're given the zeros, maybe think about using the factored form, and then going from one form to another once you have your factored form or your vertex form. If you need to find a vertex, you might want to complete the square. If you need to find an x value or a y value, you might think about maybe factoring, or even using the quadratic formula if you want to solve for x. So those are all different techniques that we can employ throughout, and you want to make sure that you practice that as you do these problems. So a lot of the problems that we're going to do today, we've seen in previous lessons, similar problems, but we're just going to see how to approach them using our different tools and techniques and how to interpret what's happening. So what I encourage you to do is to go back and try a lot of the word problems that we have done using your different techniques. I'll post some extra word problems for you to practice. And there's also some problems in your textbook that I would encourage you to try. If you go to section 6.6, there's some examples in your book. Just follow through them. The examples that we haven't done here go through those textbook problems. So you might want to try page 355, for example, for some more problems. So page 355 has some more problems for you to try, where we haven't done this one in the note, but you can try it out yourself. So there's a variety of different problems you should go try out. The more you try, the better and more comfortable you're going to become with doing these problems. You can also look at page 356 as well. So 356 has more problems for you to try out. And then there's the homework, of course, in that section. So try those out after this lesson to see that you understand how to do them. Follow the example through, because part of the math process is not just watching a video on how to do it, but also being able to follow a written example to see how to do it and to think about the steps rather than just having someone explain the steps to you every single time. You want your brain to work a little bit, and when you do that, you'll see you'll be better at doing the math. So let's go take a look at example 1. A model rocket is shot straight up from the roof of a school. The height, h in meters and t in seconds, can be approximated by this equation over here. So we have our equation given to us. And I'm going to just draw out a little sketch here because I already know what this kind of looks like. You're shooting a rocket up in the air, and you're not on the ground. So usually we assume that the ground is on the x-axis here. But you're not on the ground. You're on the roof of a school. So you're somewhere on this y-axis above 0. And you shot it up, straight up in the air. And of course it does need to come down. So it will peak, and then after it peaks it will eventually come down like this. And this makes sense for a parabola because we have a negative a value here. So you'll see the a value is negative, which means a parabola opens from the bottom. This equation could have been written like this instead. H is equal to negative 5t squared plus 22t plus 15. So it could have been written like that, again, where you see the a value is negative. And you'd have a vertex up here, which is a max vertex, and then you're starting off over here. So what is the height of the school? So what we're basically asking you is, where are you starting from? Here we're asking you, in other words, what is your y-intercept? Meaning before you shot the rocket, how high was the rocket? And when you think about that, there's a few ways you can do it. But what this really means is at time 0, where was the rocket? Which is your y-intercept. So what you can do is set time to be equal to 0. And in this case, it's easy to see that when you set time to equal to 0, your height's going to be 15, because that is the y-intercept in the standard form. And so this, again, is using our technique of understanding standard form and what the information tells us. But just to show you the work here, when t is equal to 0, h would be equal to 15 plus 22 times 0 minus 5 times 0 squared, which is basically equal to h 15 plus 0, which means that h is equal to 15 meters, and use the proper units here, meters. And you'd have a therefore statement. Therefore, height of school is 15 meters. So half the battle is interpreting the problem. How long does it take the rocket to pass a window that is 10 meters above the ground? So what we're asking you here is, when h is 10, how long did it take for h to actually be 10? So we're looking for time when h is 10. So we can set up our equation that way. We can write 10 is equal to 15 plus 22t minus 5t squared. And then we can bring the 10 to the other side to make this equal to 0. So we'll get 0 is equal to negative 10 plus 15 plus 22t minus 5t squared. I'm just going to rearrange this a bit. It's not going to change anything. I'm going to simplify and rearrange. So negative 10 plus 15 is 5. So I'm going to get, I'm going to put my t squared first. So minus 5 t squared plus 22t plus 5 is equal to 0. And so I want to find what my t value is. And you can do that in a few ways. You can try to factor. That may not work out. It might be a bit difficult to factor this. You can try to use your quadratic equation, quadratic formula. So try factoring first. If it doesn't work, try your quadratic formula next, so we can find what our time is. And so we'll do that. So our first step is basically setting this whole thing up. Our second step is solving for t using our quadratic formula. So remember that x, which is t in this case, is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. We know our a value is negative 5. We know our b value is 22. And we know our c is 5. And so what that's going to mean is that our x is going to be equal to negative 22 plus or minus square root of 22 squared minus 4 times negative 5 times 5 over 2 times 2a, so let's add that here. The a is negative 5. I'm running out of space here, but just to continue, we get minus 22 plus or minus. Let's go and find what that value is there. So we have 22 squared minus 4 times minus 5 times 5. So over square root of 584 over negative 10. And then we can go the two routes there. We can go the plus route or the minus route. So let's find both answers and see which one is the best to choose. So we have negative 22 plus root 584 over negative 10. That's one of the values. Or negative 22 minus root 584 over negative 10, and we get x is equal to negative 0.22, or x is equal to 4.62. So basically you need to make a judgment call. Are we going to do a time that's negative or a time that's positive? Well, the positive time would make more sense. Therefore, it takes .62 seconds to pass a window that's 10 meters above the ground. And so some students might be confused. They say, well, aren't you already 15 meters above the ground when you shoot it? Yes, you are. But notice that it goes up and it comes down again, so it must be passing that 10 meters somewhere around here in terms of passing that 10-meter window. So you should be able to interpret what the problem means. Think about the problem. Sometimes in the videos I've made some errors. I noticed that the answer didn't make sense based on the context. I was able to go back and fix it. So if you can think about your answer, think about the problem, and it doesn't make sense, then maybe you can go back and review to make sure you're on the right path. So let's finish up question C here. What is the maximum height of the rocket? So here you need to know that when we're asking for maximum height, we're asking for the vertex. And it is a maximum in this case. So there's a few different ways that you can go about doing that. You could find your zeros and find your midpoint value. You could and find your axis of symmetry from the zeros. You could do complete the square. You could also actually use your standard form as well. So I'm going to teach you a few different techniques to use. Right now we're going to just try complete the square. Let's do that. So let's do complete the square to find the vertex. So complete the square. We learned that method already. So again, we have h is equal to our negative 5t squared plus 22t plus 15. And so what we're going to do is we're going to complete the square by basically just factoring, taking the two terms, putting them in brackets. Negative 5t squared plus 22t plus 15 outside there. Let's factor out a constant factor. We'll factor out the negative 5 from here, just so our t squared can be by itself. So we're going to have h is equal to negative 5 t squared, or t can be by itself rather, and then do 22 divided by 5. So we're just going to keep that in fraction form. So plus, that becomes negative. Let me erase that, since we took out negative 5. So negative 22 over 5t plus 15. We need to find the number to make this a perfect square. So what we're really doing is negative 22 over 5, and this whole thing is divided by 2. So over 2 squared, which is basically the same thing as saying 22 times half, because when you divide by 2, you're just doing times half, squared, which is going to be, so 22 over 5 times half is 22 over 10 squared. And I'm just simplifying some more here. I'm going to get 11 over 5 squared. And so that would give me 121 over 25. And that's the term I need to add in there. So we're going to have h is equal to negative 5 t squared minus 22t over 5. And we're going to finish this question in the next video because we're running out of time here. So 121 over 25 minus 121 over 25 plus 15.